I actually only wanted one pony, but unfortunately, Keynote has decided I wanted three while exporting to PowerPoint. Unfortunately. Well, there we go. So essentially, we had been looking to expand into a third node for some while. And we had a whole pile of the same sort of issues that Lanop are facing at the moment in terms of equipment, sort of getting a little bit old. We're trying to decide what to do with the network and how to build it, how to grow it, and how to scale it cost effectively. And the main issue that we figured in building a new node was financial. We could break out a spur out of our network on our fiber ring, but we couldn't actually kit out the facility terribly easily, simply because it was just going to turn out to be a bit expensive. I was going to do an IXP update, by the way, but I was just a bit hungover this morning, and I couldn't make it terribly, entertaining. But INX is growing. We have lots more members, lots more traffic, lots more peering ports, and in particular, we're seeing quite a shift to 10 gig. It is just one of these things that your exchange hits a certain stage, and then all of a sudden you need like piles and piles of 10 gig ports, and we're just beginning to get into that stage at the moment. So let's go on a little bit here. Just in terms of where we are, this is a map of Dublin, which is on the east coast of Ireland, for those of you who don't know. Our fibre ring is on the bottom left-hand corner there. And you can see there are a couple... Oh, damn Google Earth, anyway. Okay, so I'm just going to nip over here. We have a couple of nodes. These were our original nodes here. Data Electronics, Kilcarry Park, and Telecity. And we have the potential of a breakout here. Our original... Sorry. Our original fibre ring didn't have this spur going off here. So we had the option of a breakout into interaction there. Just zooming in here, this is a slightly older version of this this map, which brings the network into interaction Dublin there in the top right-hand side corner. Let's just turn that off there. So yeah, looking forward, we're going to see a lot of 10 gig in the next 3 to 5 years' time. And just as sort of a general business thing, there will be network growth in terms of traffic. There will probably be network consolidation in terms of ports. And there's going to be an awful lot less growth than we've seen over the past couple of years. Our growth rate had been in triple figures, which means that we were growing by in excess of 100% a year. That's now gone down to double-figure growth, and it will probably continue to drop as market saturation occurs. But we are still growing, which is very good. We are seeing a huge drop in transit price as well. I think everybody is. I mean, you can get 1 gig off the shelf for €4 a meg at the moment, which is really dirt cheap. And if you're buying 10 gig, you probably are looking around maybe €1, 1.50, that sort of rate. So that's going to cut into our pricing model quite a lot. So the capex, and very much more important actually, we found the opex costs were really becoming quite an issue. In particular, power. And what we found was that above a certain threshold, in the IXPs, the excess power charge was coming in at around 29 euro cents per kilowatt hour. Now, if you work that out, that actually comes out as €2.50 per watt per year. Okay, so every single watt you're adding into your network is going to cost you $2.50, which is quite a scary thought. In terms of density, while the Cisco 6500s that we're using were really very good, they just offer too much port space. We simply didn't need that amount of port space. They're also very power hungry. They're TCAM-based units, ternary content addressable memory. You should have a look up on the wiki page for how it works. It's quite Wikipedia page. Sorry, so it's quite interesting. One of the problems with TCAM is it chews power. It absolutely chews power to pieces, and as a result, all TCAM switches will pull an awful lot of power. The configuration that we were looking at on the Cisco's. About 800 to 850 watts during normal operation. And then with every blade that you put in, the moment you put it in, you're talking about an extra 180 watts. All very expensive stuff. So from a technical point of view, how are we going to do 10 gig in future? And how are we going to deal with the metro fiber network, in terms of provisioning multiple ports on wave division multiplexing and stuff like that? These are all questions we had to deal with. So we had a look at how we were going to buy new equipment. Now, the first approach that we looked at was the dumb approach, which was let's see what everybody else is doing. Everybody else was kind of buying chassis-based switches. We knew that boxes like the 6500 would work very well. The RX8 Brocade RX8 would really work very well. Force 10 for our scale would be absolutely fine, and so on and so forth. We figured it wasn't really a very cost-effective option, so we pretty much abandoned it. So we talked to a bunch of vendors and sent them in a specification. You can see it there, non-contended. A bunch of features and so on and so forth. And we got replies, more 6500s, RX8 and Juniper EX8200. Now, this, I haven't put figures on this, but that was the cost graph. So the 6500 was coming in at a certain rate. Brocade RX8, a little bit more expensive, not significantly more expensive enough that it was going to, affect our judgment one way or the other. The MLX8, of course, is a router, so it's a lot more expensive. And the EX8200, well, it was an awful lot more expensive, but on the other hand, it's got a 200 gig blade to backplane capacity, and it's a beast of a machine when it works. Sorry, that came out wrong. It will be a beast of a machine when all of the features on it, which are due to be implemented, are implemented correctly. And one day it will be a really, really lovely box. It's just, at the time we were looking at it, it just didn't have the features that we needed. And it was also just way out of our price league. So yes, we had this awful moment of realization that our capex requirement was kind of going to look something like this, and our budget was a little bit closer to this. So this sort of brought us back to the drawing board somewhat. So we took a slightly different approach, very much a ground-up approach. To look at suitable products from various vendors and just see what happened. We weren't going to commit ourselves one way or the other, but we'd just see what happened. So we built a list of technical features, which was quite interesting when you sort of figure out, well, what does an exchange actually need? We wanted lots of 10 gig ports and a slightly more long-term approach to 10 gig optics. One of the problems with the 6500 is that it uses Zenpaks, and Zenpaks were wonderful technology in 2002, but that's a long time ago. We needed SFP and 10100 1000 copper. We had to have some sort of reasonable integration with our WDM system, which essentially meant 10 gig SR or LR, which is to say single mode or multi-mode connectivity. Power was an issue. We're not getting charged those insane power costs by all our colos by any stretch, but there is one of our colos where we are exceeding our power budget by a very substantial amount, and this is hurting us. So essentially, yes, we have to be able to afford all of this. This is our wish list. I'm not really going to go through it particularly. There's one or two things I want to point out here. The most important thing is port security. Without port security, or without wire speed layer 2 and layer 3 filtering, without those either or one or other of those two features, you cannot run an exchange. You absolutely have to limit your exchange to one MAC address per port. The rest of them are, quite nice to have. But really, it's 2010. We expect all of our switches that we're running on an exchange to have all of these things. Even simple things were causing us trouble. For example, the dual hotspot CPU, PSU. An awful lot of the smaller boxes will have single PSUs, or they'll have RPS units where you can plug them in, and then they take a bit more chassis space. And I don't know, they just didn't really do it for me. Obviously, broadcast and multicast storm control is pretty important as well. And optics, OEM optics, no goddamned vendor hobbling, because that is the most ridiculous pain in the ass. Essentially, you buy a transceiver, you plug it into a box, and if you have a Google for SFF8472, that specifies XFP transceivers, and there's a short memory area in a transceiver which you can read, which is called the vendor area, and the vendor will write a certain serial code identifier in there, and you can actually download the specification from ftp.seagate.com. By the way, it's quite interesting if you're into this sort of thing. But essentially, there are a limited number of transceiver manufacturers out there: Finisar, Opnext, Optway, a bunch of others, and all of the switch manufacturers will buy their transceivers, their optical transceivers, their XFPs, and so forth from one or other of those vendors. They will then take the optics, stamp their own ID code on it, and when you plug your transceiver in, the switch will certainly check it to see if it's a branded transceiver. And depending on the software revision and the vendor and that sort of thing, it might or might not give you readings on what are the optical power levels being received and transmitted, and things like the temperature of the XFP. Now, you'd think that actually that stuff probably isn't terribly important or interesting. It really is. When you're trying to diagnose a problem, and when your data center is an hour away by car or whatever it is during rush hour, you have a customer complaint, you need to be able to diagnose whether you're seeing light on a particular port or not. You just have to have this sort of stuff. So this was something that we're really quite insistent about. TDR, again, quite important. Optics. So there are an awful lot of 10 gig transceivers. Zenpak and X2 are actually the same beast, more or less. X2 actually stands for Zenpak version 2. It's a slightly different form factor. It is used by exactly Cisco and HP and nobody else. And as a result, we were very cautious about the idea of heading down the X2 route, because essentially it would lock us in to using Cisco equipment for a very long time. We felt that if we were going to go out and make an investment in terms of optical transceivers, they would typically make up about a quarter to a third of the actual cost of a fully loaded box. And that's a very substantial amount of capital investment. We didn't want to, buy a whole pile of transceivers and then, after the end of life of the box due to feature loss, we'd have to throw them away again. XFP is a very good standard, and SFP Plus was coming out. SFP Plus is essentially looks the same as an SFP, but it's a 10 gig. Inside's totally different. And there's also other sort of characteristics. You've got WDM, single mode, multi-mode, CX4. Now we had a particular problem with coloured Zen packs. You can actually get coloured Zen packs. They're very expensive, very difficult to get. They're made to order by Opnext, and Opnext are the only vendor in the world who actually make coloured Zen packs. So we did not want to go out and have to buy coloured Zen packs to light our WDM metro network. It would have worked, but essentially it would have been money down the drain. SFP Plus has some interesting characteristics, one of which is that it's extremely low power. And that's kind of good and bad. On the one hand, it'll drive down your actual power budget for your switches. On the other hand, it won't drive links terribly far or terribly long. And also it uses analog optical dispersion compensation, which means that essentially you get an analog signal from your SFP to your motherboard, and then your motherboard has to make sense out of this what you call it, analog signal. So there's essentially digital signal processing taken off the XFPs and put onto the motherboard. Now, this strikes me as being a very troublesome approach to take, because if you're an optics manufacturer, you'll typically be able to tune your DSP processing for the type of analog signal that you're expecting from your SFP. But if you're sort of having one manufacturer sort of trying to send up a sort of a decent analog signal, and another manufacturer trying to decode that, that gets into magic, and I don't really like that idea. So there's a bit of a problem there. In terms of power consumption, this is the graph of roughly how they look. Zenpack nominally is 8 watts per transceiver. SFP Plus is 1.5 or 2 or thereabouts. It's not going to make a huge amount of difference in terms of the overall budget, unless you're talking about fully loaded chassis. But it does make a small bit of difference, and it's interesting to see it as well. Obviously, Zenpack is an older technology, so it runs a bit hotter. So we were left really with XFP and SFP Plus. SFP Plus looks like it's going to be very cheap, probably cheaper than XFP. So our layer 2 choice really boiled down to switches which could take XFPs or SFP Pluses. And then if we were going to use SFP Pluses, we would pretty much have to use WDM transponders. We're using those already. This is what we're using, Transmode TM301s. Oh god damn. Yeah, what can I do? Okay, there's the last line, sort of, Keynote just doesn't always get this right. Anyway, yeah, they're very nice. This isn't exactly the configuration that we have. We've got 10 gig dual 10 gig DWM transponders, and they work very well. When you want to move it above the size of this chassis, you just get a new chassis, take all the blades out, stick them in, and everything works again. So that's quite cool. So we had a look at top of racks. Top of rack box is a 10 gig between 24 and 48 ports. Typically cut through. The chipset used on pretty much all of them at the moment is either Fulcrum or Broadcom. And these were just beginning to come onto the market in 2009. Most of them were SFP Plus form factor. Force 10 make an XFP model. Pretty much everybody else was using SFP Plus. So we started doing a beauty contest with Cisco, Brocade, and Arista. We didn't look at the other ones here for various reasons, mostly due to lack of features. And in terms of the Arista, it soon became very clear that it just wasn't going to work, mostly due to lack of features. It didn't have port security. It still doesn't. It's going to be fixed fairly shortly, but that really kind of wasn't what we wanted to hear from the vendor. It didn't support SFlow or NetFlow, didn't support Mac ACLs, and so on and so forth. On the other hand, really good latency, really good price. And this is a hacker's paradise. You can go in and you can start hacking the individual port ASICs. It's like way cool stuff. Unfortunately, I don't have one of these. I'd love one at home, but hey, there we go. The Cisco Nexus 5000. Interesting box. It runs NXOS. It doesn't run IOS or ISXE or IOS XR or anything else like that. It's running a slightly updated version of their previous fiber channel operating system, whose name is escaping me for the moment. It can also use a Nexus 2000. A Nexus 2000 is not a switch, it is a port extender. This means it has no standalone existence. If you lose your Nexus 5000, the Nexus 2000 goes down as well. It's a completely separate thing, or a completely integrated thing. It has some very odd limitations. For example, if you want to build a link aggregate, an LACP link aggregate of a couple of channels together, you can't have more than one of those channels in a single Nexus 2K box. This struck me as being possibly the most arbitrary thing that I've ever heard in networking. And I really couldn't understand it. I've been told by Cisco engineers that there are actually what they described as good technical reasons. I think that there are technical reasons for doing this. Also, it didn't actually support speeds of 10 and 100 megs. And while we would all certainly like all of our members to use 1 gig at the very least, there are certain things that, there's a lot of equipment out there for smaller members which simply don't support gig, like smaller Cisco 2800s, and so on and so forth. Anyway, that was going to be a problem, so we couldn't use that. So we thought, well, okay, we'll use a 3560 instead, or a 3750. That introduced a bunch of problems because essentially we were going to be using just different operating systems on the same in the same site. I didn't really like the idea terribly much. The boxes don't support NetFlow or SFlow, which is a pain. DOM is mostly hobbled as far as I'm aware. And the 3560/3750, it doesn't have internal support for dual PSUs. The external RPS has been fixed up an awful lot since the early days, 3550 and 3500 XL RPSs, where you could fail over to from one power supply to the other one, but actually you couldn't fail back again unless you did a reboot, which was really a bit dumb. And they had there are certain link aggregation limitations with the 3750 as well. They don't support layer 2 filtering properly, and it was not, wasn't looking good. Nexus 5000, it was a better box. The software is a little bit immature, we thought, at the stage. But actually, the power consumption was for the amount of ports was kind of crazy. And we ran our figures, or we put those figures into a spreadsheet for the nominal and the expected power consumption of the box at various loads, and it was going to be expensive. So that was that. Brocade. We had a look at a combination of the Brocade Turbo Iron 24X and the Fast Iron Edge Switch X624, which is the IPv6 capable model. The TI-24X is completely new again. It started shipping in August 2009, which is to say it actually arrived at the end of September. But I guess it, Andy, did it get caught in customs? Or I'm just being mean to Andy now. It's a pretty good compliance with our technical list. There were still a couple of problems. It doesn't yet support IPv6 ACLs on layer 2 ports, which had various knock-on effects like not supporting RA guard and a few other things like that. Neither device supported remote port mirroring, which was a bit of a pain. The Cisco's didn't support it either, so there wasn't anything we could kind of really do about that. They don't really support digital optical monitoring. Brocade's position on this is that there's no religious opposition to it within the company, but unfortunately, when it gets down to it, some models get shipped and they support it, and some models get shipped and they don't support it, and some software revisions get shipped with or without it. So I'm going to beat Andy up about that a little bit later as well. It also took a little bit more work to integrate with our provisioning, or it would have taken a little bit more work to integrate with our provisioning system, but hey. Nominal power consumption, way less than the Cisco Nexus 5000. Both switches supported multiple power supplies, which was really good. There was no messing around with RPSs, and that was a definite advantage. And the Foundry Metro Ring protocol is really a much saner approach to bridge management than per VLAN spanning tree, which is just a horrible, horrible kludge. Unfortunately, it's the kludge which we're stuck with right now, but we are planning to get rid of it to a certain extent. So we decided to go ahead with the Brocade box. On the cost basis that we bought them, we were actually able to kit out 2 POPs for 45% of the cost that we would have paid for kitting out a single POP with our previous solution. That's a slightly embarrassing figure for a variety of reasons, and I'm not sure whether it says we did quite well on the new procurement, or whether our old procurement procedures were really lousy. Probably a bit of both. And the boxes actually dovetail rather nicely into each other. The 24X has a couple of 10, 100, 1000 ports, which are just really useful to have on a box like that. And the Fast Iron has a couple of 10 gig ports, which also are really useful to have. The go live for Interaction Dub 1 was actually happened at the end of October 2009. Slightly delayed due to unforeseen circumstances. And Interaction Dub 2 was supposed to be actually at the end of January 2010, but the unforeseen circumstances in that situation were that the data center wasn't ready. We should have fiber connectivity in there this week, and it should be. We should actually have we should technically be able to provide live services there at the end of this month. Now, one of the reasons I'm over in London at the moment was to spank these switches, which Lynx were extremely good, and I'm hugely grateful to them for allowing us to hook them up to their Ixia testing kit. And we did a bunch of tests, RFC 2544 throughput testing and latency testing. And by judicious configuration, we have confirmed that the Turbo Iron handles line rate 80 gig full duplex. That's 80 gig in one end and out the other, and 80 gig sort of in at the other side and at the first side, and sort of snaking through the switch. At 64-byte packets as well, which is rather good. We're very pleased about that. The latency is very good, 5 microseconds, about 5, a little bit over 5 for small packets. The Fast Iron also did really well. We were pleased to see that it did line rate 64-byte packets. I was a bit skeptical in advance that we were actually going to see good results from this, simply because I just don't believe marketing figures at all, ever. But they worked, it delivered, and we're really pleased about that. We did find one rather odd cosmetic bug. While the SNMP stats and the packet count stats looked accurate, the line rate, where it says 300 second input rate and output rate, it kind of got to a certain stage and then it went to 0. Fairly minor, a little bit annoying, but not particularly important. Unfortunately, we weren't able to get to test line contention. The Ixias were just having a bad hair day yesterday, and it just wasn't possible due to that and due to lack of time. So anyway, we contention is a little bit of an issue on a cut-through switch. On a store and forward switch, you deal with contention by having huge input buffers and output buffers, whereas on a store and forward switch, so for example, if you take, say, for example, let me think of the switch, an EX8200, some of the 10 gig buffers on those cards would be, I think they're about is it 160 or 200 megs per port? Something absolutely stupendous. Now the Turbo Iron 24X has 2 megs of buffer for the entire box. You actually don't need any more in theory, because when you're sending in a packet and it's being diverted to a congested port, you simply turn on flow control and tell the issuer to stop sending any more data, and then it'll wait until the port is decongested again, and then flow control will tell it to restart the transmission, which causes issues on the other side. So unfortunately, also we did find that there were some features missing. Port security was due to be shipped in the original version of software. Unfortunately, we found out that it wasn't, much to our Brocade SE's surprise. It's not the end of the world. It will be fixed in a release which is due out very, very shortly. There are a couple of annoying limitations with layer 2 ACLs on the FESX 624. And 1 or 2 limitations in terms of port grouping, which means that for a particular port group on the switch, you can either enable snooping or you can enable S-flow, but you can't enable the 2 of them. So whenever you're doing quarantine, you have to disable S-flow on a bunch of ports. Irritating, not the end of the world. So this is what we got. On the left-hand side, that's our old network of Cisco 6500s. In fact, we've switched one of them out for a Brocade FESX 624 and have brought our power consumption down from 850 watts to 125, which is really good. On the top right is Interaction Dub 1. Bottom right is Interaction Dub 2, as it will be connected up fairly shortly. Shortly, we will be planning to bring the Interaction Dub 1 to Dub 2 link to be multiple 10 gig, and that's going to mean CWDM SFPs. We think we're going to get away with it fairly easily because, in fact, that fiber link is only it's 800 meters one side, 1.1 kilometers the other side. So that's kind of easy to deal with for CWDM. So we're not expecting any real problems there. I didn't get a pony, and I particularly didn't get 3 of them. So that's all. Thank you very much. Yeah, sure.
Oh, okay. Just on the optical cartridge thing, don't you think with Cisco and HP going down that route, the volume that they'll drive will have a big impact on price?
That's one of these things that Cisco just decided to do. They have stated publicly that the reason that they went for X2 was because it was the largest volume shipping transceiver in the world, which is rather circular because it was only the largest because they actually started shipping X2, so it didn't really make much sense. My suspicion is, and I would say that this is only a suspicion, is that they continued shipping X2 products because the electrical interface is fully compatible with Zenpak X1. So that meant that they didn't have to do any radical board redesigns. So on a Zenpak and on an X2, you have 3 by or 4 by 3.2 gig channels, and then you have your SerDes on the board, and you have your SerDes maybe on the maybe on the line side as well. And you have your LAN-PHY actually on the transceiver, whereas on an XFP the PHY is on the is actually on the board. You have a 10 gig electrical interface, and it's just kind of different. So I think probably they just saw that in fact it was going to be cheaper for them to use slightly older designs, which worked reasonably well, rather than going for SFP pluses or XFPs.
Wonder if the big HP and Cisco falling out might who knows?
Who knows?
Yeah.
I think the thing you've got there, Neil, is half the designs are already sort of like so locked years beforehand. It's probably going to be a while before you see any difference from that. That's my take on it, just as another consumer of networking goods.
Okay.
Any further questions for Nick? No, thank you very much, Nick. Cheers.